So, dear friends, once again, welcome. Let us do this problem. This problem we have done by using the vector approach. Now we have to solve this problem by using a scalar approach. So once again, reading the problem statement: five vertical forces are acting on a horizontal plate as shown in figure. Find the resultant of the forces and a point of application with respect to using a scalar approach. Okay, so this is the plate. Okay, and five forces. What are the five forces? This one first, F1, F2, then F3, then F4, and F5. And what are the axes? This is X1, the coordinate, this is coordinate system, this is X, and this is Y, here Y, Z axis. And the dimensions are given here. So this is 5 meter. This 5 meter is parallel to Z axis. Okay, means Z axis dimension of this plate is given 5 meter. And what about the X axis? So X axis here 4 meter plus 2 meter. So X is equal to here coordinate is 6 meter. Origin here, origin, this is the origin of the plate. Okay, and just identify. Let us solve this. So our system name is force system, and which type of force system? Which type of force system? So it is the, you can see here, the parallel force system in space. So all the forces are acting parallelly, either downwards, mostly downwards, or upward. So here the main thing, this problem we have to solve using scalar approach. The vector approach, already this problem is solved by the vector approach, and that is given in the comment box. The link is given, so you can refer that. Okay, let us compare vector approach, vector method versus the scalar method. So until unless it is asked, it is suppose I specified the method either vector or scalar. If it is not specified, so dear friends, you just opt this scalar method to save time. So suppose it is asked to opt the vector method. So what are the in vector methods? What are the steps? So procedure here, first is coordinate to find the coordinates. Second is force vectors like F1, F2, F3, and so on. Third one is position vectors like R1, R2, R3. Fourth one, that is moment vectors. Vectors means M1, M2, M3. Fifth one, resultant force vector are resultant. So it is summation of all force vectors. Then 6-1, that is resultant moment vector. And here there are two steps, like to get a summation of moment about O, and it is summation of all the moments. Okay, and suppose there is couple, so C1 plus C2 C3 like that, and the second B, it is A and B, then that is we have to apply moment of resultant force about origin, that is MR, and that is equal to MR is equal to ROP, cross product of resultant. Okay, and where P is the point through which resultant acts, and this ROP is position vector of the resultant from the origin. Okay, then the last step, that is 7th, we have to apply the Varignon theorem. So that is summation of moment about moment of the resultant. Okay, so in this way there are 7 steps. So you can see first what is we need to find out the coordinates, then force vectors, then position vectors, then moment vectors, then resultant of force, then resultant moment vector, then the moment of this one, moment of resultant, then the last one, Varignon's theorem. So in this way it becomes lengthy, and if you compare this video with the previous video that is given in the comment box, the link is given, then you can see, you can compare how much the scalar method is easier than the vector method. Okay, and in that video what I did, uh, after that the in this question resultant we have to find out. Okay, and also what about its a position, means P, X, Y, Z. So this resultant lies in X and Z plane. Okay, so that's why Y becomes 0, and X we need to find out, and Z we need to find out. So for that what I did, I started, mostly we don't know what we have to get, what is our objective. So that's why in that video I started from the reverse. Means ultimately what we want to know, this we want to know. Okay, so how to get, so from the 7th. Okay, then what is the moment of summation of moment of origin, and what about the moment of resultant? In this way, to get this we have to follow the 6th one, then 5th, then 4th, then 3rd, then 2nd, then 1st. So that is the means just for better understanding, and that from the reverse I solved it. okay, but it's your choice, and obviously we should start from the first step, but that you should know how to get that. That's why I started from the last. It means how to get the R and P, so that we can get from the Grignon's theorem, and what are the terms involved, like a moment about O and MR, so moment about O, how to get, so from here we get moment about moment of resultant, how to get, so from here we get, and what are the terms associated with them. Okay, in this way I solved. So these are the 7 steps that you have to remember if you are going to solve the problem by the vector approach. Okay, now let us solve this by the scalar approach. So scalar approach is very simple. Scalar method we are going to solve. Okay, what we have to do, we have to find out the resultant first step. The resultant we have to find out, and that is the all the forces except F4 are acting downwards. Okay, so F1, F1, F2, F3, F4, F5, these are the forces. There are 5 forces. So F1 minus 3, F2 minus 5, F3 minus 6, F4 plus 2, F5 minus 7. Okay, so only the, why they are plus 2, so you can see here F4 is acting upward, that's why we are taking positive. Okay, so what we get, we get 90 kilonewton. Okay, the second, what we have to do, we have to take moment about x, and that is r into z. It is not the cross product, not the cross product. Okay, and so it is what, it is the Verignon's theorem. Verignon's theorem. Okay, so how to get the moment about x. So in the x direction, what are the forces lying in x direction? So F1 and F2. Okay, so for that the distance, perpendicular distance, we won't find, no perpendicular distance, no perpendicular distances. Okay, and what about the other forces? So let us do it. Mx is equal to, and what about direction? Direction, suppose we are taking this clockwise. Suppose negative we are taking, suppose. So this F1, and the distance, so better to write the value. Okay, so what is F1? F1 is equal to 3. So that's why 3, and it is multiplied by 0 s for this. And what about the F2? So minus F2 5 multiplied by 0, because it lies in x direction. And what about 6? So see here, suppose the, this is the P, the resultant. Okay, here this is vertical line, it is resultant, and from P, this is the P, and it is parallel to x-axis, and it is parallel to z-axis. z axis. Okay, so 6, which force we are talking about? This force 6, this one. So the perpendicular distance will be what? For this it will be the this 5 meter, this length from x, this is the from x, it is the means it is parallel to z axis. That's why the z axis coordinate, that is 5, we have to take. And what about this one, f4? So direction is here anti-clockwise, yep, we are taking positive, so it is 2 and multiplied by what? The same 5. Okay, and what about this f5? That is 7 multiplied by 5. Okay, and there is a one mistake, this will be minus sign. Okay, because all other forces f5, or you can say f3 and f4 and f5 are distanced 5 meter from the x axis. Okay, that's why this one we have taken. So what we get actually from this summation of mx, from that we get mx is equal to, we get minus 19z. And here one thing more, Wegners once again, here the summation of moment x is equal to r and z. Okay, so summation of mx is equal to what we get, the here once again writing this, so it is what, it is 30, then 10, then 35 is equal to r z, and r already we know, that is minus 19. Okay, so is equal to, we get z is equal to, we get 2.89 meter. Okay, so z we got. Now we have to get x coordinate. So how to get? So summation of moment we have to take about z, then r is multiplied by x here. Okay, it is multiplied by x. So that is equal to, once again here copying pasting that, this okay, so this how to get moment about z. Okay, so what we have to do, this is our vertical line, this is our resultant, and the coordinates p, and from here to here, okay, this is z, this is x. Okay, so moment about z now. So what we will get moment about z. So this f1 lies in the origin, that's why minus 3 into 0. And what about f2? So here this f5 5 minus, then what about the z? We're taking moment about z, so that's why x distance is required, means how much? So x distance is here how much? It is 4 plus 2. 4 plus 2. Okay, and then the f3, so f3 is positive and it is 2. Sorry, f3 is, the value of f3 is 6. So 6 multiplied by this one, 6 multiplied by the again the x coordinate we require, so that is 6, and again this we have to do minus. Okay, what about this f4? So here it will be 4, this force is here 2. Okay, and the perpendicular distance, that is from this 4 meter from the origin along the x. Okay, what about the last one, this f5? So minus, I'm going to write here minus 7. And what about, so it lies in the z-axis, that's why 0 is equal to this rx, so rx is minus 19x. So by solving this we get x is equal to 3.05 meter. Okay, then the next step this one is second, and then moment about z, the third step. Fourth, that is resultant, and it's a point of application. So we know r with negative value, and the direction, it is in y direction, so that's why z, and it acts. Now we have to write the points, the coordinates, points p, and that is 3.05, 0, then 289. So this is our final answer. It is our final answer. Okay, so with this we have completed, and if you compare, see, so scalar method, there were only 4 steps. Firstly, we need to get the resultant, then we need to apply the Verigne's theorem 2 times. Okay, 2 times we need to apply Verigne's theorem, because we wanted to know about the coordinates, means x is what and z is what, that's why 2 times. Okay, and after that we came to know what is our x, what is our y. So the last step, writing that resultant with the position. So in this way we have done, and this we can compare, means how the more computations are involved in case of, from this we came to know from solving the same problem by both vector and scalar approach. We came to know that vector approach is more computationally expensive, means more calculations required, and more calculations then more time. So जब तक ना बोला जाए तब तक आपको you have to opt the scalar method.